All right, things get really crazy here. Follow me closely. F of x equals 2x and is graphed below. So this is the graph of f right here, f of x. And g of x is defined as this ridiculousness. Okay, let's interpret that and make sure we understand what it's actually saying. G is equal to the integral from 0 to x of f of t dt. Okay, now we have another variable involved. So here's the deal. We are going to be finding listen closely, the accumulated area from 0 to any x value for this function. So why doesn't this have an x? Because you already have an x. Let's not overuse x. That's my best explanation for it. But the best verbal explanation or written explanation for what this is the accumulated area from 0 to whatever x value for the graph of f. For f, just f. And the f of t dt, well, this is the x-axis. Don't worry about the t. This is just a different variable saying we're using x already. Okay, for f of, I'm going to call it f of x, call it whatever you want, f of x, f of t, whatever. Okay, f of x, or f of t, is defined as 2x. So what I really have is this. G is the accumulated area from 0 to x of f of t. So instead of x, we'll put a t, so 2t dt. All right, let's dig back in some notes. Find some older notes, and here's what's really happening. I just want you to see it. Here we go. We are accumulating area from -2 to 4, and the function is 3. We're accumulating area from -1 to 2, and here's the function. Accumulating area. I didn't use that phrase in this lesson, but what I'm really doing is just finding the area. So I'm finding the area from 0 to wherever I want to go on this graph. So let's go. Here it is. Here it is. I'm going to write a whole bunch of stuff down. G of x, where x is 0. So I need g of 0, which is the area from 0 to 0 of 2t dt. Now, if this looks confusing, this one's the easy one because I'm going from 0 to 0. I have accumulated 0 area. Okay, this might look confusing. It'll get cleared up in just a second. G of 1 is the area from 0 to 1, the definite integral from 0 to 1 of 2t dt. 2x dx, if you want to think of it that way, but again, we already had an x floating around in here, so let's not complicate things. So here goes. This is what we're dealing with. I want to find the area from 0 to 1. I want to find that area right there. So what is that area? That area is exactly, well, triangle. 1/2 1 times 2, because the height would be 2, and that would give me 1. Okay? We're going to do the same thing here. G of 2, which is the area from 0 to 2, 2t dt. Oh, 2t dt, what do I do with that? That's just this graph, okay? Just the graph. Don't panic. This tells me I'm going on the t-axis, and we are using the graph of 2t. All right? But we're going to go from 0 to 2. So I need to find the area of this. I don't need to worry about coloring it so well because it still looks terrible. So 1/2 base height. It's going to give me 4. Okay, if you already notice a pattern, that's good. If you don't, it's fine. No problem. G of 3 equals the area from 0 to 3 of 2t dt. We're going to color some more. So we're going to also find this area, whole thing, not just the extra stuff I'm shading, but the whole area from 0 to 3, bad coloring, we'll deal with it. So from 0 to 3, so it is, triangle, 1/2 base times height. I'm gonna get 9. Do you notice the pattern in the answers? 0, 1, 4, 9. Okay, Just let's work with it here. We'll keep going. G of 4 is area from 0 to 4 of 2t dt, and that is 1/2 all this that I've already shaded plus this extra piece right here. There we go, shading one thing at a time, one extra little piece at a time. And it's 1/2 base, which is 4, height, which is 8, and that's going to give me 16. Okay, you know the next one, right? Of course you do. G of 5 is the integral from 0 to 5 of 2t dt. Again, this is just the function that we're using to dictate what area we're finding. 1/2 5 times 10, and I'm doing that because, well, you see it, you know it. There it is. And I get 25. So at this point, we have to sniff the pattern out if we haven't sniffed it already. So the function, I'm gonna put my final answer up here in red, make it stand out. The function is, well, 0, 1, 4, 9, 16, 25. What numbers are these? They are perfect squares. So when I'm finding the area, in this particular case, for any given integer value, I end up with the perfect squares. And so what I really have, if I plugged in a 1, I got 1. If I plugged in a 2, I got 4. If I plugged in a 3, I got 9. If I plug in 4, I get 16. If I plug in 5, 25. If I plugged in a 6, I'd get 36. If I plug in 10, I get 100. This is equal to x squared. Okay? I'm just saying. Just saying. All right. This is going to lead us in an amazing direction in the next few lessons, in the next few videos, but in the next few lessons. This is going to be huge. Okay? Let's slide up. If f of x equals 3x squared, it's graphed below. G of x is defined as that. Okay, similar idea, just different definition. So G is the integral from 0 to x of f of t dt. Well, instead it's going to have 3t squared, so 3t squared dt. And a table of values is below. Write a logical expression for g. So in this case, I'm not going to make you find it all because it's not going to be obvious. Like here it was, oh, triangle, 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 and here it's curve, and I'm not quite sure what it is. So the area from 0 to 0 is 0. The area from 0 to 1 is 1, and I know you're like, that's not 1. Well, look at the scale on the y-axis. Okay, keep that in mind. That's one reason we can't quite do this. This area is 8. This area is 27. This area is 64. This area right here is 125. Okay, what are these numbers? 0, 1, 8, 27, 64, 125. What are they? They, my friends, are the perfect cubes. So if I plug in a 1, I get a 1. If I plug in a 2, I cube it and get an 8. If I plug in a 3, I cube it and get a 27. If I plug in a 6, I get 6 cubed, which would be 216. Big idea is that this is x cubed. Okay. Don't want to give too much away, but I do want you to look at the relationship between x cubed and 3x squared. Just take a minute. I'm not going to tell you what the relationship is, but you probably see it. And I want you to look at the relationship between x squared and 2x. Okay? These are very closely related. X squared and 2x have a relationship. X cubed and 3x squared have a relationship. And I want you to think about what that relationship is and think about how we undid that relationship by finding area. Okay? We're going somewhere with this.